Welcome to this Physics Viva Voce video focused on the Hall effect. We will cover the fundamental concepts and practical applications of this important phenomenon in solid-state physics. Let's begin with some practice questions. Question 1. The generation of a potential difference across a perpendicular magnetic field is known as the Hall effect. Question 2. The magnetic field, current, and Hall voltage in a standard experiment are mutually perpendicular. Question 4. Hall voltage is directly proportional to both the magnetic field and the current. Question 5. Hall voltage is inversely proportional to the sample's thickness. Question 6. The Lorentz force is responsible for deflecting charge carriers. Question 7. The Hall coefficient, RH formula, is 1 over n times E, where n is the charge carrier concentration. Question 8. Thermal conductivity cannot be directly determined by the Hall effect. Question 9. The SI unit for the Hall coefficient is meters cubed per coulomb. Let's review the answers for questions 7 through 9. The formula for the Hall coefficient is 1 over n times E. Thermal conductivity is the material property that cannot be directly determined. The SI unit is meters cubed per coulomb. Question 10. A zero Hall coefficient indicates that electrons and holes cancel each other perfectly. Question 11. Hall mobility is related to conductivity and the Hall coefficient by the relation mu h equals sigma times RH. Question 12. Semiconductors are preferred for sensors because they produce a larger Hall voltage due to lower carrier concentration. Question 13. For metals like copper, the Hall coefficient is typically very small and negative. Question 14. Reversing the magnetic field reverses the Hall voltage polarity. Question 15. The angle between the applied and resultant electric field is known as the Hall angle. Here are some core concepts. The Hall effect is the transverse potential difference across a current-carrying conductor in a perpendicular magnetic field. It is caused by the magnetic Lorentz force. The Hall voltage formula is current times magnetic field divided by carrier concentration, thickness, and elementary charge. The Hall coefficient, RH, is defined as 1 over n times E and determines the sign and density of charge carriers. A positive RH means the majority carriers are holes, typical for p-type semiconductors. The effect is more prominent in semiconductors due to their lower charge carrier concentration. In the steady state of the Hall effect, the magnetic force is balanced by the electric force from the accumulated charges. The Hall angle is the angle between the primary and resultant electric fields. Applications include measuring magnetic field strength using Hall effect sensors and determining semiconductor type. Let's summarize the important Hall effect formulas. Hall voltage is V H equals I times B over N times T times E. The Hall coefficient is RH equals 1 over N times E. Hall mobility is the product of electrical conductivity and the Hall coefficient. Thank you for engaging with this video on the Hall effect. Stay updated with more physics and engineering tutorials by sharing this video, subscribing to the channel, and pressing the bell icon.